Hey, let's do this. It's College Board. It's still Unit 4 because this is a large unit on probability. And so this is still Unit 4, but Part 2 because I've did 2 weeks worth of this. So the first one we're going to do is 2018, problem number 3. And so what it starts out with is talking about this area and multiple births. This is an interesting problem because I kind of wonder about that from Alito. The kind of probabilities that we have here, I wonder if our probabilities of multiple births are the same as everywhere else. And so that's something we could look into. But here we go. 3.5% from that area are multiple births. And so then that means then the other part of it, so 96.96.5%, so 0.965 are single births. Then they talk about of those, so this is conditional. So of these multiple births, then we've got 22% who are left-handed. So let's take a look at this number right here. So this is the number of overall who are multiple births and left-handed. Okay. All right. But then we have our single births, and then we have the left-handed proportion of those because it's 11% and right-handed. And so these are the left-handed ones that, or I'm sorry, the single births that are left-handed. Now, let's first talk about how did I know that this was a tree diagram problem that I wanted to do? So your clue is that if you have multiple conditional probabilities, the tree diagram is the strategy for me. Multiple conditional probabilities, the tree diagram is the strategy for me. And I could tell that by this language. Of the children from here, so given that they were from here, it's one probability. Given that they were single births, or given that they are multiple births, it's one probability. Given that they're single births, it's a different probability. So we had two conditional probabilities. That's how I knew tree diagram was a strategy for me. So then they asked, what's the probability that they are left-handed? So that's the sum of these two sections I have check marked here is the multiple births and left-handed and the single births and left-handed. So I wanted to add those two together. All right, so to get credit for that section, you had to show some kind of strategy of how you got those parts. It didn't have to be a tree diagram. You could have just written, in fact, you could have just written this here plus this here. Knowing I want multiple births and left-handed, and I want single births and left-handed. So if you could just show the sum of those two things and you would get credit there. All right, so did you show that strategy? Did you show that it was the sum of those two products? And I had done that, and then you got the correct probability. If you got all those, you got your first essentially correct. The next question was, okay, what's the probability then that a randomly selected child born in the region is a child from a multiple birth, given that the child is left-handed? So again, I want to remind you that here on the formula chart, and so then this is the front of that formula chart, we have this given that formula right here. So this is given that they are multiple births. So I want to put the total, actually no, that it said given that they are left-handed. So I want to put the total left-handed ones on the bottom. So what that meant is that even if you missed the part A, they expected to see the carryover from what you put in part A on the denominator of part B. So again, if you missed part A, whatever answer you got there, whatever this answer is, should be the proportion who are total proportion who are left-handed. So that's on the denominator. And so then of those, given that they are left-handed, of those who are left-handed, who were the multiple birth left-handed, that has to be that intersection. And that intersection is that area up at the top. So that was this first thing that I had highlighted right here. That is the intersection of multiple birth and left-handed. So that was your numerator. And so what we got as a final answer was 0.0676. You don't have to have this sentence here, okay? But they needed to see this correct numerator and denominator, and of course, that left-handed based on part A, and then the answer. So let's look at the actual grading. Yep, numerator and denominator. Because, well, and then this would show that correct carryover from the values in part A. All right. Notice that they did say in this grading guidelines that if there were minor arithmetic errors or a transcription, like when you carried it from part A to part B, if you just flipped a number or something, then that was ignored without penalization. Okay. And so then you got the correct answer of 0.0676. So if you got all three of those correct, you got an E. If you just showed the answer without work, you have a partial, okay? And so now let's look at this last part. This one was saying then out of 20 children, what's the probability that at least 3 of them are left-handed? So again, we are using that left-handed probability from part A. So we are still carrying over that information from part A. So here's a strategy for you. Say you had no clue how to do part A, but then you knew for some reason how to do parts B and C. You could legit make up an answer in part A that's plausible, that's reasonable. And then, so just say you didn't know the answer, but you just put a number there, say 0.25. Okay, who knows? And then you carried that down properly in these two problems here, then you could get full credit for parts B and C. All right, so don't let being stuck on a part A deter you from looking ahead at the other parts. All right, but here we wanted at least 3. So here again is our binomial formula that you should be seeing from the formula chart. So let's take a look at that. So here we're doing something in this format. So again, this is that out of 20, I want 3 successes. And then that is the success probability and how many of those I want. And that's the failure probability and how many of those that I want. So that looks like this. Now, you had to also show that collection of 3 up to 20 is what I wanted. So a couple of ways, so I showed that here. I want the 3 up to the 20. So this helped me know that I wanted to show the work for 3 and then continue that pattern up to 20. And that's how I got my answer. Now, in the calculator, this is what I did, which that was not required to speak. But I will tell you something interesting that counts as work for binomial formula. If you would have simply written 1 minus binomial CDF, and you defined these parameters, n equals 20, probability equals 0.1139, and then x equals 2. If you had done this right here, you would have gotten full credit. So that's interesting. So that's something that, I definitely do want you to realize that defining those parameters could be done this way at the very least if you do not understand this binomial formula. So let's take a look at your credit for that. So you indicated binomial C, because let's take a look at that calculator speak. If you had written it the way that I did, I indicated binomial, and I indicated this, and I indicated that. I included by doing 1 minus, I included the correct direction with the end point as being 2 and below. So what I wanted was 3 and above. So that one calculator speak covered all those 5 parts. And so you can get a full, and then of course that correct probability, 0.4020. So you had to get all 5 of these correct to get an E. To get it a partial, you had to indicate binomial with an N of 20 and a probability of whatever you got from part A. And then any one of these right here. So something, if you could get credit for any of these, then you could get a partial. All right. So, 2 or 3 of these parts. So 2 or 3 of those. Why do I have 5 things? Okay, I'll have to look into that. But anyway, so then to get credit, let's see what your final score would have been for this. If you got 3 E's, there's your EEP is a 3. Many different ways you could get a 2. Okay, so EE, EPP. If you think about a P being a half a point and an E being a full point, then this is kind of like a 1.5, and this is a 1.5, and these were both 2s. Okay, and then those were 1s. All right, moving on. So our next problem was 2017, problem number 3. So here we had 2 years in a row where a very similar probability problem was problem number 3, okay? Because a probability problem will be one of the ones that you are going to be doing in your free response. So first, we're talking about these watermelons or whatever kind of melon these are talking about. But we had different distributors. We had distributor J and K. And so this grocery store purchased different amounts based on which distributor they came from. So there you can see that's conditional upon which distributor they came from, having to do with some things there. All right. So first, they gave you a normal model with a mean of 133 and a standard deviation of 5, and they wanted to know if it came from distributor J, then what proportion? So what is the probability that they would have, so what proportion or what probability of getting one from distributor J that was 137 or more? So then that's my X value. And I really should have labeled this picture better. I should have put 137 here, and then I should have labeled the mean and putting there at 133. So written that 133 in and done those that way. So that would have been the best way. And, I should have taken care of that when I did that. I would have put 133 right here and then done some kind of shown what one standard deviation above it was. Okay, and then also put 137 here because that's what my X value was that I was testing out. All right, so all those kinds of details, remember, because when we're talking getting credit, you had to indicate the normal model with a mean of 33 and a standard deviation of 5. The ways you can do that is by showing the picture. Okay, and so a picture is always the best way to make sure you have got that. Notice if you had put an X bar for 133, you would have gotten that wrong. X bar, it was the population mean of 133 and the population standard deviation of 5, not sample mean or sample standard deviation. All right, also, this would have gotten me credit for normal model as well, because indicating that z-score with the z tells normal model as well. But we're not so good at putting z equals, and I found my students lack doing that consistently. So that's why I just say picture, 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 draw a picture, draw a picture. All right, next you have to put that boundary. So that is that mark of 137. And then direction. So that is your shaded area. So by putting this boundary at 137 and shading this area, you just checked 2 boxes in the criteria that we wanted, and then calculating that correct probability by norm CDFing that from 137 up. All right, so see if you got all 3 of those things correct. And then I marked 2 boxes, but anyway, or 4 things, but there was just 3. All right, so next, let's move on down to the next part. The next section was, then it told you the proportion of distributor K that were that criteria of at least 137. So from distributor K, it was this proportion of them are greater than 137. And from distributor J, it was this proportion that were greater than 137. So they want to know the total proportion that are greater than 137. But they don't purchase half and half. They don't do half from distributor J and half from distributor K. So you can't just do those half and half. see, they'd take more from distributor J. 70% come from distributor J, and that probability, that's the proportion of those 70% that are large enough. And then you sum that with the 30% that come from distributor J, and then the proportion of those. So overall, they would expect about 40% of their melons to be greater than 130 or 137 or more. Okay, so let's see here. Interesting. K is non-organic. Do we know J is, see, J is the organic ones and K is the non-organic ones. Okay, so that's why they had a much different probability proportion that were, they were probably, sprayed with the whatevers to help them grow and all that kind of stuff. Okay, so one of the methods that you could have done this was either this strategy here of 70% from J with this probability plus 30% from K with this probability to get that total. You also have two conditional probabilities, just like we had on the previous problem. So here, see, look, this was 2 years in a row that they had very similar type problems. And so here we had a tree diagram. We had conditional upon you coming from J. This is the rate that you had greater than 137. And they saw that you carried this over from part A. So once again, if you had missed part A, then they would have looked to see that you carried this number right here over properly from part A. Okay, and then distributor K and this. So you wanted these two pieces. So in our grading guidelines, we want to see that we had a sum of those two weighted probabilities. Many different strategies you can do. You could just do the sum of those two products. You could show them here in the tree diagram. Okay, so any of those things there, and then that you came up with that correct probability. So if you got both of those correct, you got an E. If you just put the answer down with no work, you got an I. Oh no, you got a P. You did get a P. But that's surprising. A lot of nowadays, they pretty much give you an I if you do not even show how you came up with those numbers. All right, and then the last one, part C. Here we go. See, here's a given that, a conditional probability, a given that. So we're going to be using this formula here. Given that it came from, let's see what it said. Given that it came from, given that it is greater than 137. So what they are looking for is that you bring your answer from part B down here as the denominator. So out of all of these, what proportion of those were from distributor J? So out of the total that were greater than 137, this is the part that was distributor J portion. So that was this piece out of the total. And so here's how your credit came about on that. You had the correct numerator and denominator. The numerator came correctly from part A and 7. So this could even be like a two-step. The grader is going to have to look all the way from part A, that you had 70% of what you brought down from part A right there. And then the total that you got from part B as the denominator. So this was a tough grade from the grading standpoint, in that if you missed part A, then we have to follow that incorrect answer all the way through B and through C. But anyway, so we were using our calculators to calculate your information based on those. Okay, so you showed that work. So we could follow your answers down, and if you got both of those correct, you got an E. So take a look at how you did on this problem. 3 E's, you got a 4. 3.5, you got a 3. Here is the different ways you can get a 2. Okay, those are two full points, and this is kind of like 1.5 point, and then just one correct, you get a 1. All right. So those are two very similar probability problems, recognizing all that conditional probability and finding it on the formula chart, recognizing the binomial and how to handle that and show the work on that. All right. So I hope that Unit 4, Part 2, helped you to do better on the free response probability problems on the AP exam this year. Thank you.